The following presentation will provide an overview of the GSX pin setter. At the bottom of some of the slides are common error codes associated with the various assemblies. In order to effectively communicate with others about the pin setter, we have established a standardized naming convention. As with all Brunswick pin setters, we refer to positions and movements as if we were standing at the left front corner of the machine. Even though majority of the time we are approaching the pin setter from the back, we always refer to the 10-pin side as the right side of the machine and the 7-pin side as the left side of the machine. The pin setter consists of 8 sub-assemblies. In this presentation, we will cover the first 7. They are the ball pit, the ball accelerator, the pin elevator, the distributor, the setting table, the sweep wagon, and the drive frame. The electronic control will be covered in a different presentation. The ball pit consists of the ball cushion and the pin curtain. The ball cushion stops the ball and guides it through the ball door into the ball accelerator. It is a large metal frame with 2 wooden boards attached to it. The bottom board has a rubber facing bonded to it, 4 plastic impact strips mounted along the bottom edge, and some heavy fabric strips that comprise the cushion flap hanging down on the ball return side. The cushion is mounted on 2 plastic bearings that allow it to pivot back and forth, and a shock absorber is mounted to control its movement. On the opposite side from the shock is a rubber stop and an adjusting bolt. This is used to adjust the position of the cushion at rest in relation to the ball door opening. If it is adjusted to cover up too much of the ball door or too far behind the ball door, it can cause problems with the balls being able to exit through the ball door opening. The cushion flaps are designed to help keep pins waiting to be taken up the elevator from rolling back in front of the ball door and being taken through the ball door into the accelerator. The impact strips will wear over time. The ones behind the 7 and the 10 pin take the most beating for missed corner pin attempts. The impact strips can become cracked and may be a source of ball scratches, or compressed impact strips may allow balls to travel under the ball cushion and allow serious damage to the ball. The pin curtain stops the rearward movement of the pins and creates a black background behind the pin decks. The transport band brings the pins to the elevator and keeps the ball rolling along the ball cushion while it's guided to the accelerator. The transport band is like a big wide conveyor belt. It is tensioned between 2 rollers. The transport band rotates around 2 wooden boards that help support the weight of the pins and ball as they travel to the back of the machine. An open area between the rear board and the rear roller provides a more flexible area for the pins being returned from the distributor to contact, thereby reducing stress to the head and neck of the pin. The rear roller is belt driven and is mounted to the frame by spring tension rods that are used to adjust the side-to-side tracking of the belt on the rollers. There are 2 tracking rollers mounted under the front board that also help keep the belt centered on the rollers. The ball accelerator is mounted between the 2 pin setters, and the ball door is open to allow a ball to enter from either lane and onto 2 plastic-covered rods mounted on a pan. Above the rods is a wide flat belt tensioned between 2 drums. The rear drum has a motor incorporated into it. With a standard motor, the housing is mounted stationary, with the shaft spinning to drive the belt. With the accelerator motor, the shaft is held stationary to the frame, and the housing spins around the shaft, acting as the rear drum to drive the belt. The rods are raised in the center, and as the ball travels up the rod, it increases the tension on the belt, allowing the belt to propel the ball to the power lift. The constant pressure of the belt pushing the ball against the rods can loosen or break the bolts that mount the rods to the pan. Loose accelerator rods can result in balls being scratched, or even in balls coming off the track underground. Both the accelerator rod and the accelerator belt assemblies can be unbolted and slid out the back of the machine. The ball accelerator motor is protected by a thermal overload in case balls or pins jam the belt, and trips the motor contactor before damage to the motor or balls occurs. The ball door and ball door locking assemblies prevent balls from opposite lanes from entering the accelerator at the same time. As the ball travels down the face of the cushion, it contacts a button on the face of the door. This button pivots a lever down and allows the door to swing open under a locking bolt. The button prevents pins from entering the accelerator as they strike the door while moving toward the back of the elevator. When a ball triggers the machine, a solenoid attached to the locking bolt pivots it even lower, blocking the door and keeping it from opening even if the button is contacted. The 5 seconds the ball door is blocked prevents even a ball from opening the door and allows enough time for the pins to travel to the back of the elevator. As one door swings open, it blocks the door from the other lane. The pin elevator receives pins from the transport band and carries them up to the distributor. Pin feed deflectors on either side funnel pins into the elevator shovels. Proper adjustment of these pin feeds help prevent pins from idling on the transport band. Coming up from the bottom, pin deflectors help guide the pins as they load each shovel. Halfway up, an ejector gently wiggles the shovel to knock off extra pins or pins not properly seated on the shovel. As these wear, you get less wiggle, and that may allow more than one pin to reach the top of the elevator. Above that is a pair of centering wedges that center the pin on the shovel. At the top, a shovel guide tips the shovel forward, allowing the pin to roll out onto the pin guide wedges mounted on the shark assembly. You use the shovel guide adjustment along with the shark level adjustment to ensure that pins are delivered base first and not head first onto the distributor. A switch on the back of the elevator is contacted by each shovel. The pin setter program monitors this switch and stops the machine if something jams the elevator and prevents it from moving. The distributor removes the pins and positions them so the setting table can receive them. The distributor consists of a shark assembly, 4 pin feed lanes, 2 crossover lanes, 10 pin stations and associated distributor stations, and left and right overflow chutes. The numbers 11 through 16 and 31 and 32 on the drawing correspond to the error codes for jams on the pin feed lanes or the overflow chutes.
As mentioned earlier, the shovel guide rolls the pins off the shovel. The pin guide wedges turn the pin so it enters the distributor base first. As the pins roll off the shovels, they actuate a pin count switch. The pin setter program counts the pulses from the switch and energizes a solenoid which flips the shark back and forth to deliver pins to the right or left distributor lanes. It delivers pins 1 left, 1 right, 2 left, 1 right. The program then repeats itself.
The pins move down the distributor lanes until an empty pin station is found. At the empty pin station, an ejector flap sticking between the 2 round belts will cause the pin to fall onto the pin station's retaining bow. This will lower the ejector flap and allow any other pins traveling along the distributor lane to move on to the next available pin station. The pin is held into the pin station until the setting table is ready to receive that pin. The retaining bow will release the pin when the pin holder's gripper pushes up on the pin release lever. How far down the button on the pin release lever extends is adjustable. Making the button length shorter reduces the distance the pin must fall when being delivered to the pin holder. Though if it's set too short, when the setting deck is at the home position, the open gripper will not push up on the pin release lever enough to unblock the bow and allow the pin to be delivered to the pin holder. As some parts wear, they can contribute to unreliable delivery of the pins to the pin holder. The movement of the bow will elongate the slot it sits in the pin station housing, and it'll also wear a groove in the pivot pins that secure the bow to the housing. The tab on the bow that is blocked by the pin release lever can chip off. The stud the pin release lever attaches to can get grooved, causing erratic operation of the pin release lever. Metal tabs at the bottom of the distributor stations that direct the pins into the pin holders can get bent, causing misloading. Or the part that mounts the distributor station to the distributor frame breaks and fails to hold the pin on the bow. Black slider mounts on the distributor stations can also break and allow pins to misload. Any pin that does not find an empty pin station is returned to the transport band through an overflow chute at the ends of each outside distributor lane. The overflow chutes have been redesigned to be rubber mounted. These mounts fail before the chute breaks, reducing the cost of maintenance. The overflow socks have been redesigned to be more durable and are also better at delivering pins more horizontal to the transport band. This reduces impact wear to the transport band and also less impact stress to the neck of the pins. If no bowler activity occurs within 90 seconds, the distributor motor will shut off to save energy and reduce wear on the pins in the pin setter. The setting table is a multi-purpose assembly. It must be able to detect for standing pins after the ball has been rolled. It must close the spotting tongs and pick up the pins standing on the lane to allow the sweep to clear the deadwood. It must receive pins from the distributor and set them on the lane for a new frame. Each pin holder has a switch that serves two purposes: to detect standing pins and detect when a pin is loaded in the pin holder. The pin holder has a switch lever. The switch lever is actuated by either the switch finger or the switch button. A pin delivered to the pin holder pivots the switch finger, which actuates the switch lever. In addition, the pin detection paddle contacts the switch button, which also actuates the switch lever. The switch lever is designed to change the status of the switch from either open or close, regardless of whether a pin is loaded in the pin holder or not. For detecting pins, the pin setter program is only concerned that the switch changes state, not whether it is initially open or closed. The pin holder is subjected to wear, which can result in unreliable operation. The forces of the operation of the solenoid not only wears grooves in the pads on the housing that hold the solenoid securely, but also wears the tabs on the solenoid housing where they rub against the pads. The mounting hole of the switch lever gets worn and creates too much play in the lever, allowing it to bind on the switch or not actuate the switch reliably. The operation of the plunger in a loosely held solenoid wears or cracks the collar on the coil in the solenoid. A cracked collar can inhibit the plunger from being fully pulled into the coil, and this can lead to unreliable operation of the grippers. The switch finger can crack, and the pivots of the switch finger get grooves worn in them. The area where the switch finger contacts the switch lever wears a groove in the lever and can result in unreliable switch actuation. The paddle pivot pins get grooves worn in them and can result in unreliable pin detection. With the setting table at the home position, the pin holders are held in the horizontal position by a latch that holds the number 4 swing shaft lever. When the table needs to go all the way down to set new pins, a square shaft is rotated by the stroke limiter solenoid to release the latch. A roller mounted on the number 4 swing shaft lever contacts the arm of the ST1 jam assembly and allows the spring on the number 1 swing shaft to rotate the pin holders vertical as the table lowers. The same roller overpowers the spring as it contacts the arm on the TS1 jam assembly as the table raises back to the home position, where the latch on the number 4 swing shaft can again hold the pin holders horizontal. When the spotting tongs need to be driven open or closed, a solenoid mounted on the table drive gear assembly energizes to engage a gear clutch with the table drive. This drives a shaft mounted across the distributor to a planar gear. The other side of the planar gear rotates a square shaft that runs down to the right side of the table, where a series of gears and tooth racks drives the spotting tongs open or closed, depending on whether the table motor is turning clockwise or counterclockwise. The bottom of the table has 9-inch cutouts at each pin position. The spotting tongs are designed so that even if a pin slides off spot, it will be able to be picked up and set down anywhere in that 9-inch circle. If the pin slides outside that cutout, then the machine will stop with an out-of-range error code. Since the pin setter relies on the pin contacting the pin holder paddle to read the pin count, The bowler must manually input the pinfall on and out of range. When the tongs are closed, the connecting links are driven over center to lock the tongs and prevent pins from dropping from the table when raised for clearing deadwood. The spotting tong has a drive gear that contacts the tooth rack and is attached to the table with a self-tapping screw. To adjust the spotting tongs in the closed position, remove the self-tapping screw, lift the spotting tong from the tooth rack, and turn the drive gear until the connecting link is driven over center. At each side of the setting table is a table rack tube. These are used for guiding the table as it raises and lowers. The right-hand tube has a chain attached to it that routes over a sprocket mounted on the top of the guide tower to a crank arm attached to the table drive shaft. The left-hand table rack 2 has a T-stop on the top of it. It stops the lowering of the setting table at the pin detection height when it comes in contact with the stroke limiter plate. The plate is pulled out of the path of the T-stop by the stroke limiter solenoid when the table is to be lowered all the way down to the new pin setting height. The sweep wagon is lowered as soon as the machine is triggered. It keeps pins from rolling back on the lane, protects the table as it raises and lowers, and sweeps deadwood from the deck. The components that comprise the sweep are the sweep drive motor, drive gear and sweep arm shaft, the sweep release assembly, the attenuator and shock assembly, and the sweep wagon itself. The sweep is held up by the sweep release assembly. To lower the sweep wagon, the sweep release assembly's solenoid pulls the swing lever rearward, allowing the tipper to rotate and drop the sweep wagon. A sweep attenuator, along with its hydraulic shock absorber, slows the dropping motion. When the sweep is in the guarded position, the function switch G is actuated by the attenuator. Once the sweep is down in the guarding position, the sweep motor turns the sweep drive gear clockwise. This rotates the sweep crank arms and drives the sweep arm shaft rearward and then forwards. The 6 guide rollers mounted on the sweep wagon assure that the wagon rolls smoothly and squarely in its sweep path. When the sweep crank arms make one complete rotation, a cam on the right side crank arm activates the sweep motor switch. The sweep motor shuts off and its internal brake engages to prevent the motor from coasting. This allows the sweep to be stopped exactly at the fully forward position. Near the end of the pin setter cycle, the table motor and sweep release assembly work together with a pivot link to raise the sweep. During a pin setter cycle, the table motor runs twice. The first time it runs counterclockwise. During this time it will be unable to raise the sweep because of the position of the sweep release chain and sweep release assembly. During the second half of the cycle, the table motor will run clockwise. This rotation positions the tipper on the sweep release arm under the tipper roller on the sweep wagon, lifting the sweep along with the table. The tipper can only come in contact with the roller when the table motor is turning clockwise. The left drive frame assembly consists of the 3 pin setter motors along with their drive systems and the stroke limiter assembly. The front motor is the distributor motor. It is a 1/2 horsepower motor without an internal brake. It uses a double pulley system to drive the front distributor shaft, all the distributor belts, the shark assembly, the elevator, and the transport band. The center motor is the sweep motor. Its function is to drive the sweep rearward and forward. This 1/4 horsepower motor has an internal brake that stops the sweep in the forward position and prevents coasting when the power is turned off. The rear motor is the table motor. Its main purpose is to raise and lower the setting table. This motor is the only one on the machine that turns both clockwise and counterclockwise. It also drives spotting tongs open and closed, and it raises the sweep wagon at the end of the cycle. The 1/2 horsepower motor has an internal brake that locks the motor shaft when the motor is turned off. This is an overhead shot of the 3 motors along with the switch cluster housing and the front distributor shaft. Notice that the front of the machine is on the left-hand side. The stroke limiter assembly determines whether the table lowers to the detecting height or the new pin setting height. It consists of a stroke limiter plate, a hydraulic shock absorber, a solenoid, and a square shaft. The plate and shock absorber slows the table as it lowers for a short stroke to detect or respot pins. A solenoid pulls the stroke limiter plate out of the path of the T-stop located on the top of the left-hand table rack so that the table can lower fully to the new pin setting height. It also rotates the left-hand square shaft to unlatch the swing shafts and allows the pin holders to rotate vertical so new pins can be set on the line. The right drive frame assembly contains the switch cluster housing and the guide tower assembly. The switch cluster assembly contains 4 switches labeled A, B, C, and D that inform the pin setter CPU of the setting table position. The operations that occur as the switch cluster cam passes each of these 4 switches will be discussed at a later date. The right-hand guide tower is bolted onto the pin setter drive frame. At the top is a sprocket on which the table chain rides as the table is raised and lowered. An out-of-range switch is used to determine if the table was lowered to the proper detection height. The table jam switch TS2 activates if the table cannot return to its home position. This concludes the pin setter operation presentation.